Hey everyone, welcome back to Papa's Workshop. In the previous video, I showed you exactly step by step on how to assemble this machine. And in this video, I want to go through and show you the next steps that you need to do that's not covered in the manual before you carve that first project. Now, one of the things that it said in the manual is how to square this machine by using the gantry, moving it all the way to the very rear, tighten those screws, and then move it all the way to the front and tighten those. Well, we're going to check for squareness and see if the machine is actually square. That's one of the things that's very, very important. Now, the other thing I want to do is show you the features of this machine and why this would be a good choice for you to have in your shop. According to the instructions now, I've tightened all the screws and this machine should be square. But is it truly square? That's what we're going to find out. Because if it's not, I want to be able to make that correction now before that first carve, because that will cause problems when you're doing your different projects, especially if you have some very close tolerances that you need to be able to maintain. Especially, for an example, if you're doing tiling. Now, granted, with a machine this size, more than likely, tiling of a project is going to be minimized. But here again, you may have a project that still needs to be tiled, and this machine needs to be perfectly square in order to effectively do that. Even if you're not doing tiling projects, I still think it's very, very important to have this machine as accurate as you possibly can. And to do that, it needs to be perfectly square. So let's check it out and let me show you how I square the machine to be able to make sure that it's truly accurate. A lot of people will just use a tape measure, and you can measure from one corner to the next. The problem with this method is that you really can't get into the corner. I can go to that spot, but I can't get into this corner to be consistent. So I can have quite a variation. So that's 87.5 inches, but it's really not in that corner. So is this the best way to do it? Measure diagonally with a tape measure? I actually say no, but just for curiosity, I want to see how close it is using this method. That's 88.5. Let's switch over to the other side. If I switch over to the other side and try to get this lined up, it actually comes out to closer to 88.75. But there's still a lot of variables in this. How accurate is the opposite end of the tape measure in that same position in the corner? And am I really measuring to the exact same point? It's really hard to tell. So I want to show you a better way to be able to check for the squareness of this machine. So let's get rid of the tape measure altogether. Now what I'm going to do is use 2 sticks to be able to measure this. As long as these 2 sticks are over half the distance, this method will work. Let me show you how I do it, and it's actually more accurate than using a tape measure. I'm going to take the 2 sticks and literally spread it across and put it right into the corner. And I'll put this one in the corner. And then I'll just bring the 2 together where they're a nice straight line right there. So you can see this end is right in the corner of the machine. And this end, likewise, is right in the corner of the machine. So let's check the center now and mark where these 2 pieces of wood intersect. I have these 2 pieces of wood where they overlap, and I want to make sure that they are in line in this direction. So that looks real good. And then I want to take and mark a pencil line right there. So that's going to be the measurement for the first diagonal right there. So now let's switch over and do the same thing on the opposite diagonal. Now we're going to do the same thing. We're going to line this up where it's perfectly straight. There's no gap along this area, and we're going to mark it. These lines should be exactly the same. So you can see that there is a gap here. So the long side was the first measurement, and this is the second one. So we need to actually square this machine up so that there's one line right there in the center. So here's the question you have to ask you. The distance was 5 millimeters. Is that 5 millimeters being out of square enough to cause a problem for the type of work that you do when you're looking at that diagonal of roughly 2,255 millimeters? So if you want to take the percentage of that, I'm not going to do that math. I'm going to see if I can get it a little bit closer and reduce that 5 millimeters down to less than 1. Because literally, I want this machine as accurate as I possibly can get it. I'm going to loosen the screws on both sides, and I'm also going to loosen the screws along this wasteboard, because all of that provides the stability that you need. Now this is going to take a few minutes to do, and part of it I'm going to do off camera. Now in hindsight, I think when I put the wasteboard itself together, perhaps I could have been a little bit more accurate, but that's okay. We're going to correct that right now by loosening these screws and making this correction. The ideal time to have checked for squareness was when I was putting the wasteboard together. I failed to do that, so that is my fault. The reason that I didn't, I saw such a precise measurements when I was putting the wasteboard together. It seemed like it was going together perfectly fine and perfectly square. But in hindsight, I should have checked it to make sure that it was perfectly square, because it would have been a lot easier to adjust it there and not after this machine is totally finished. Now, it's still very important to be able to keep these two sides, the Y1 and the Y2 axis, parallel. So what I'm going to do is start the machine and bring the gantry all the way down to the front. And then we're going to measure it again, and we're going to make those small adjustments until we get this machine perfectly square. This is one of the most often overlooked features on the controller. This is the e-stop. This is an emergency stop switch. Oftentimes this is actually depressed in shipping, and when you first turn on the machine, nothing's going to happen. So if that is pressed down, it's not going to work. You have to rotate it in the direction of the arrow, and you'll see this little switch will pop up. Make sure this is done before you start the machine. I've turned on the controller now for the CNC machine, and I use the Open Builds software, which is a free software, and I find that I like working with this one better than other controllers. So this is what I use, and when I turn this on, it comes up with the connection point at the COM6, and this is what I'm looking for, the CH340 on that USB port. I'll actually come up and click connect, and that will start it. Now you'll see I have an alarm up here. That's okay, that's supposed to be there. We'll click and get rid of the alarm, and the first thing I want to do is not home the machine. We're just going to move this all the way to the front. So I'm going to click this. I'm going to do it slowly. I'm going to click this on the 100 millimeter and then move this on the y-axis. This will ensure that the Y1 and the Y2 axis remain parallel to each other. So I now have the X-gantry, this gantry all the way forward. So the Y1 and the Y2 axis are still parallel, but because this was the long axis when I measured diagonal, I actually need to shift everything just slightly to the right. Now I've shifted this ever so slightly to the right. Now I'm going to remeasure it and see how we did if we close the gap on that 5 millimeter. So after making the adjustment, here's the results. The first measurement is on the outside. That second measurements are right there in the center. That is a 1 millimeter gap. I think I can live with that because I started out with 5 millimeters and now I'm down to 1 millimeter. And I think that is good enough because I'm looking at a diagonal distance of just over 2,255 millimeters. And if I can get down to 1 millimeter variance, I think that is going to be well within the accuracy that I need. So I'm very pleased with that. So now it's time to go back and tighten everything. Next thing I want to do is go through and home all. So I'm going to come up to this right here, click on it. And now it's going to move to the back right hand corner. So the machine is now homed in that far back corner, and this is actually perfect. So now when you're setting up your project, you have all this open space to be able to work to lay out your project, and the machine is out of the way. I want to make sure now that everything moves in the correct direction. We've already done the y-axis, which is the negative, pull it all the way forward. I want to be able to move now on the x-axis, and I can see that it goes in the correct direction. If we want to go back into positive, so that all works. I want to bring it forward some so I can test the going to the back again. And we'll test this one. That works perfectly. Now the next thing I want to make sure is that the z-axis moves in the correct direction. So I want to make sure now that it'll move down. So that's great. And will it move up? Yes. So I now know that all of the axes are moving in the correct direction. The next thing that I want to check is the calibration. Now when the machine comes to you and you set everything up, the Gerbil settings inside the controller should be set and be accurate, but you never know. Mistakes do happen, and it's a good idea to be able to check it. So what do I mean by calibration? For example, if I move along the x-axis and I tell the computer that I want it to move, let's say 200 millimeters, does the machine actually move 200 millimeters, or is it moving something less or more? If it's moving something other than what we had said and put into the computer, then we need to calibrate it. And we'll do that on the X, the Y, and the Z axis, just to make sure that it's perfectly accurate. And if necessary, we'll make the changes. Now I do have a couple different videos out there on exactly how to make the changes. So I'll put that link in the description also so that you can take a look at it should you need to see that video. But right now, let me show you how we're going to check the calibration of this machine. Now to begin this test for the calibration, I want to put in a very sharp point bit into the machine. And the bit that I'm going to use is this one right here. This is a 60-degree V-bit. It has a nice sharp point on it. That will work perfect. The first step, I want to remove the nut that holds the collet. Now this is an ER11 collet that comes with this spindle. To remove the collet, simply push it over to the side and you'll hear a little click and then it'll slip out. Now this one is set up for 1/8 of an inch. And if you look real close, we'll try to get this up close in the camera, it actually says 1/8 inch right there. The bit that I have is 1/4 inch, so I need to get another collet to put in there. In the kit that comes with this, you have the 1/4 inch collet already in your package. So there's no need to have to go out and buy one. Now what I would suggest doing is being able to get these set up like I have. I have this one set up with the 1/4" collet in it. And I also have one that's set up with the 1/8". I'm going to put this one back in. And all you do is just snap it in place just like that. And it's in there. And that way, if I need to change bits, I don't have to pop out these collets each time. I just change the whole entire nut with the collet in it. I'm going to take the 60-degree V-bit that has the 1/4" shank on it and put it into this ER11 collet that is a 1/4". And then I'll just slip it back onto the spindle. Now at this point, I really don't need to tighten it because we're not turning the machine on. All I'm really using this V-bit for is that nice sharp point to be able to measure and check the calibration. The next step I want to do is take the spindle and bring this all the way down to just above the wasteboard. And we're going to line this ruler up so that we can measure off of the millimeters. Now I've almost reached the limit on my limit switches, so I'm actually going to lower the spindle itself, and that's something else that needed to be done. Now I can lower that down, but I don't want it touching. I want to raise it up just a little bit, and then I'll tighten it there. This is just one more step that we need to be able to do before we start that first carve. All these little things, they seem trivial, but quite frankly, they're all important to be able to accomplish. Okay, so now we've actually got the spindle adjusted. I'm going to raise this up just a little bit. So here's the setup. I put a pencil mark on the wasteboard right down here at this end, and I also have another one down at this end. And it doesn't need to be a large mark. It's just a little small pencil mark so I can put this down exactly where the router bit would be traveling. And it's at each location, so I have a perfect straight line for this router to be able to follow. And I lined up this exactly on the 100 millimeter mark. So that way, this is a perfectly straight line that's going to correspond to the movement of the x-axis as this spindle moves across. I'm going to start right at the exact 100 millimeters. That's just a good starting point. And then we're going to move it along this axis and see how it moves and if it corresponds to what I'm telling it to move. And then of course we'll move back. And that is as close as I can get. So now I'm going to go over to the computer and we're just going to move it 100 millimeters and from here to here and see what it looks like. And looking at this, the first 100 millimeters is perfect. But to get a true test, we need to move all the way across. 200, 300, 400, and 500, 600, and 700. Let's see what it looks like now. So if we look at that, that is dead on perfect. So that looks really, really, really good. So the calibration on the x-axis we know is correct. Now we're going to repeat this and do the same thing on the y-axis. And I'm just going to do this off camera because the procedure is exactly the same. I do want to double check. We're going to move it to 700 millimeters back and make sure that it ends up right at that 100 millimeter line. So that's about as perfect as you can get. So real happy with that. Checking the calibration now on the z-axis is a little bit more challenging. But what I've done is just taken a small ruler and I taped it to the side of the z-axis. And then I took a blade and I put it right exactly on the 10 millimeter line. From there, I can move this up 10 millimeters at a time and check to make sure that the z-axis is also calibrated. I want to zoom in real close so that you can see that, and you can see it's exactly on that 190 millimeters. So that moved exactly as it should, so the Z-axis is perfectly calibrated as well. At this point, I've checked to make sure that the machine is square, and we've adjusted it, and I showed you how to do that. Also, we checked to make sure that the machine was calibrated on the X axis and on the Z axis. The Y axis I actually did off camera, and it was 100% accurate. There was no reason to change any of the calibration. Now, I will have a link in the description to a video that shows you exactly how to do the calibration on this machine or any Gerbil-based machine. I'm not going to actually go into the settings on the open build software because, one, there's no reason to, and how you access those settings vary between the different software. Whether you're using the open build software, if you're using easel, if you're using the UGS, all of those, you access it differently to be able to get to the G-code. But once you're there, how you enter the data in is basically the same, so that video will definitely help you should you need to calibrate your machine. And I would suggest saving that video so that you have it available to you anytime in the future should you need to calibrate it. Because quite frankly, yes, I have had machines lose the calibration, and I've had to start completely over and calibrate the machine from scratch. So it does happen. So at this point, I want to talk about some of the special features that this machine has that you may or may not find on any other machine that's available to you. First thing I want to show you is how the limit switches work. The first thing I want to talk about are the limit switches. You have this pin and this pin. That gives you the two extremes as far as the movement of the Z-axis. You have an inductive limit switch, meaning that when this machine moves up, passes this sensor across this pin, it will stop. Same thing if you move it down. This inductive limit switch passes this pin, it will stop. And to show you as an example, I'm going to do that. We're going to move it up and we're going to have it hit this limit switch. It doesn't touch anything. This is all electronic. What I attempted to do is move the Z-axis up 10 millimeters. When this inductive switch came in contact with this pin, the machine stopped, and it stopped before that 10 millimeter. Now it doesn't touch anything, it's just an electronic sensor. So at this point, the machine will not move. In the computer itself, it says clear the alarm. So we're going to click that. We're going to attempt to move it down. I'm just going to move it down 1 millimeter. And it is free to move. It doesn't take anything else. So it's just that easy to be able to reset it. I want to show you the same setup right here. Here is the pin, and this little block is a hard limit. So this is the inductive limit switch that would come in contact with this point. And if for some reason this failed, this is a hard stop, so it would trip the alarms here. To give you a better view of that switch, this is what it looks like on the back of the X-axis. And if we were moving this on the X-axis and it came over to this point, it would stop right here at this point when it reached this pin. You have multiple choices as the spindle options for this machine. Now you do have a number of options on the type of spindle that you use. Now what I've decided to do is go with this one. This is a 710 watt spindle that comes from the Genmitsu. You also have the option, if you wish, you can use the DeWalt 611 router. And they do have available water-cooled spindle, and you do have the option to be able to put a laser in here and run this machine as a laser engraver. On the front of the controller itself, you have a plug-in for a laser 1 and a laser 2. Why two lasers? Well, let me explain. You have the option with this machine to be able to add an additional Z-axis. What that means, you're going to be able to double your productivity, and that includes being able to run two lasers versus the two spindles, your choice. Now you do have the option of purchasing a second Z-axis and actually mount it to this machine, which basically means you're going to have two heads. You'll have one over here and one here, so that you can actually double your productivity by cutting out the two projects at the same time. So running a small business, if you're doing multiple projects, you can add this Z-axis over here and be able to have a dual Z-axis system to be able to run. Another feature that you have on this is this dust cover. These covers help protect that lead screw so that it's not going to get excessive sawdust and materials into it. So this is a really nice feature to be able to protect that. And you can see up here, this one is protected also because it's located behind this plate in here. You can actually peek inside and you can see it in here. So it's well protected. In addition to having dual linear guides on the x-axis, you also have the linear rails on the Y1 and the Y2 axis. Plus, you have the 20mm ball screws. And you actually have dual linear rails that the machine rides on. You can see the linear bearings in here where it moves across on the x-axis. When you look at the ball screws on the machine, this is a 20mm, so that is a significant size for good stability and for very effective carving and stability that you need to have. In addition to that, you have these linear rails and you have the linear bearings in here. You have a very large working area to be able to carve the large projects without having to do the tiling operation. That is a huge convenience. And of course, this is a massive work area. You have a 4-foot by 4-foot working area, which means you can put a half a sheet of plywood on this wasteboard and be able to carve your projects. And that is so nice. It really will eliminate probably 99% of any need to be able to do tiling operations, because this way you're able to do the whole entire project in one process. I homed the machine again to see exactly how far back that it would go, and then I took the tape measure and measured this distance. And you literally have just over 1,300 millimeters, and I wouldn't go any further than that, so let's just call it 1,300 millimeter working area. And then if I rotate this around, going to the maximum in this direction, the maximum was here. Again, 1,300 millimeters would be about as much as I would use, and that would still give me a little bit of room. So a 1,300 by 1,300 working area is just phenomenal. Next, let's look at the closed loop stepper motors that are included in this machine. And you have the closed loop stepper motors, and it's capable of running 5,000 millimeters per minute. You have the standard puck to be able to measure the Z-axis and to probe this. Plus, you also have, included with this machine, a built-in probe that's right here in the wasteboard itself. Now, one of the things I want to point out too, you do have available a Genmitsu app that you can control this CNC machine with, and you also have the wireless control kit that plugs in right on top of the controller. Now, that's something I'm going to be experimenting with in the future because, quite frankly, the internet speed that I have down here is minimal. It works hit and miss, and I don't want to be in the middle of a project using a wireless controller and have the machine kind of go on its own path because it lost a signal. So that's something I'm going to have to experiment with. But if you have a good strong signal in your shop, then this is a real good consideration to go wireless with the Genmitsu app and control it with your phone. So at this point, the machine is totally calibrated. It's square. We've moved the trim router to the proper location so that we can have everything ready to carve. I've also shown you the limits and the features and the benefits of this machine. In the next video, we're actually going to be carving some projects. I've got several different projects in mind already. Some of them are quite large, and we're going to be testing out this machine real soon in the next video. So thanks a lot for watching. I really appreciate each and every one of you for visiting my channel. I hope you was able to learn something and see just how wonderful this machine is. And if you liked the video, by all means, give me a thumbs up. Subscribe right down there below, because that really does help the algorithms. Leave me a comment on what you think about this machine and what type of machine that you have, or what type of machine are you considering purchasing. I would love to be able to hear from you. So until next time, where we actually put this machine to work and start doing some carvings. So bye-bye everyone. Thanks a lot for watching.